So, the answer key for last night's was, well, I don't know if it was posted, but the video had all the answers. The answer key might have been posted too. It was, okay. All right, so the idea that we were looking at last night was solving trig equations, but they were really, really, really simple trig equations. I know that Miss Martin brought in some stuff the other day that she was working on with Math 3 where they were doing this in Math 3. However, you know, how far you get with trig stuff might vary from year to year. So, so this type of solving trig equations is in Math 3, but it's basically just searching for where the trig value has that answer, right? And we were talking, it also talks about looking for principal values, right? So for sine and tangent, principal values is your first quadrant and your fourth quadrant. For cosine, it is first and second quadrant. Yeah, third gets no love at all. And what this does, so like whenever you use your calculator to solve problems involving trig, and you do an inverse sine or inverse cosine, what we've been learning is like sine and cosine values just like repeat themselves over and over and over and over and over again. So like if 50 degrees is an answer, then if we take 50 and add 360 to it, 410 is also an answer. Then we can add 360 to that again, and that'd also be an answer, right? So what the calculator does whenever you use it is it only gives you principal values, right? So it gives you a single answer, although technically there are infinite answers. Usually the principal value is the one that we need. There is one case you have already seen where the principal value was not the only one you needed, and that was when we were doing law of sines and we had that ambiguous case, right? Because with law of sines, ambiguous case, we got one answer, but there was another angle that would have worked as well. So that's an example of where like the principal value is not enough. So so for some problems we will be asked to solve for principal values, which most of the time is going to give you a single answer, although we'll see some times where you can get two there. Other times they may ask you to look at the whole unit circle. I am not going to give you any that ask you to give all answers because there are infinite answers to these. So to do that, you have to put like all this like plus 2 pi k integer stuff that we are not going to go into. Because technically, if I ask you for all answers to where does sine of theta equal 1/2, there are infinite answers because it's pi over 6, but then it's also pi over 6 plus 2 pi, or plus 4 pi, or plus 6 pi. So that's a short little explanation there. Did anybody have any trouble with this or questions last night? Anything? Did it make sense what you were doing there? Okay, so when you're doing principal values, and this is on the beginning of this one as well, when you're doing principal values, those fourth quadrant values that we have on our unit circle, they're marked like 270 up to 360. However, principal values for sine and tangent are from -90 to +90. So when you look at those values on the unit circle, you're going to see that it's like 300. But you have to give an answer that's between -90 and 90. So those fourth quadrant values, you want to use negative degrees for that. So if you take whatever the answer looks like on your unit circle, so if you get 300, if you subtract 360 from it, it will give you that value. Or you can also just think about looking at it. So if I pull up the unit circle here, oh wait, fourth period's working on Radian's the snowman for my door. So he's coming. Hopefully. Well, that didn't help. That's not good. There we go. So like on this unit circle, when you're finding an angle, like if your answer is over here at 300, rather than giving 300 as the answer, you have, if it's fourth quadrant, you have to do negative 60 there, which positive 60 is right here. So if you just go the opposite direction, that same amount, that would give you this here. All right, so let's look at some problems that are a little bit more difficult. So we're going to do our examples first, and then you'll see that last page is your homework that you'll do. So we're going to do these examples together. So, and I'm going to actually split screen this. So now I encourage you to try, whenever you're doing these problems, try them without looking at, oh, good gracious, where they put the unit circle itself. There we go. All right, so I'm going to pull this up so I can like point out places on the unit circle. But I encourage you, whenever you're doing this, it will make you better at the unit circle if you try to do these without looking at your unit circle the whole time. If you try to do them with like with your mind or just sketching like a little piece of the unit circle, it will help you get better at the unit circle. Whenever you guys are going to test on this on Friday, on everything we've had so far, and on that test I will give you a blank unit circle, so you can fill it in from the beginning if you want, or just use it as needed, whatever you prefer. You won't have to turn it in. It will just be for your own use. So, but the more you can do this without actually looking at the unit circle, the better you will become at this. I'll show you what I mean by that here in a second. So, if I am doing this first example, and I want to solve this equation right here for theta, then I need to try to get the trig function by itself. So I'm just going to subtract that 1 from both sides. So sine of theta will equal negative 1. Now we're just basically at where we were yesterday, right? So to find theta, I need to think, where does sine of theta equal 1? Essentially what you're doing is you're doing sine inverse, but this is not going to be on a calculator active section. Sine inverse, whenever you're doing sine inverse, it means where does sine of theta equal negative 1. That's what you're doing whenever you do sine inverse. So you don't necessarily have to like write that step, but that's what you're doing. So if I'm thinking about my unit circle, now I'm going to point it out over here in a second, but I tried to do this without actually, try to just think about it. And so I'm thinking sine is sine x or y coordinate. Y coordinate. So y coordinate is going to be negative 1 right here. There's 0, negative 1. It says principal values. So on the unit circle, that's 270. But 270 is not between negative 90 and 90. What do we call this instead? Negative 90. So we would say theta is negative 90 degrees, or we could also say theta is negative pi over 2. For the problems we're going to do today, I'm going to give both answers. The way that you'll see this whenever it shows up on the quiz or the test is that it will either tell you whether to give radians or degrees, or it will be multiple choice in radians or degrees, so you will know which one it's asking for here. But I'm going to do both because it's just helpful to see both, I think. Yes, yes. So like right here where I'm getting 270, if I subtract 360, because that's going to be a full rotation, that gives me my negative 90 degrees, which is in that range from negative 90 to 90 that I'm looking for. Good. And it'll sort of take care of itself a little bit on ones that are multiple choice. Because if it says solve for principal values, I'm just going to list like all of the possibilities from negative 90 to 90. So 270 won't be an answer choice. So you'll have to stop and think, well, what's the same as 270? Okay, questions on number 1? Also, I should note right here, these problems look a little like trig identities, but if it says solve, you can move things from one side to the other. I should have mentioned that on this first problem, but you saw that I moved this. So if it says solve, you can move things from one side to the other. You cannot do that with trig identities on the on the quiz that you just had. You have to work on both sides there, or one side or the other. But if it says solve, you can move things from one side to the other. And if it says solve, you need to get an answer like 90 degrees or 45 or something like that. All right. For example 2, I've got cosine of theta minus 1. So I can add 1 to both sides. 2 cosine theta is going to equal 1. What would I do next? Divide by 2. Cosine of theta equals 1/2. So I'm thinking, where does cosine equal 1/2? Is that my x or my y coordinate? Is x. I'm thinking on my unit circle. I'm actually looking at it here, but the more you can do this without actually looking at it, the better. So cosine is 1/2 right here. That is 60 degrees. So I've got theta is 60 degrees. And I would also get, if I want to do that in radians, that is pi over 3. At 120, you've got negative 1/2. So it would not be. Now, it is true that 300 also works. So why did I not put 300 as an answer? Cosine is first and second quadrant, so that is not a principal value. We are going to see some questions. I don't know if it does it today. I think today I'm just doing principal values. We're going to see some questions tomorrow where they don't ask you for principal values. They basically ask you for the whole unit circle. And if that's the case, you would put 60 degrees and 300 degrees as answers. But for these today, we're just doing principal values. So we get these 2 answers right here. All right. Okay, the next one, it looks a little more complicated. And it is going to be a little more complicated, but the main reason it's more complicated is because we're dealing with tangent instead of sine and cosine. Tangent is not on our unit circle, right? We're going to have to think a little harder to figure out what this is. But we still want to get that tangent by itself. So I'm going to subtract 4. So I got 4 square root of 3 tangent of theta equals negative 4. Then I will need to divide both sides by that 4 square root of 3. So tangent of theta is going to equal, the 4's are going to cancel, so I'm going to have negative 1 over the square root of 3. And you can rationalize it if you want. I don't know if we're going to need to or not. Tangent's not on our unit circle, though. So if I'm looking at the unit circle, first of all, I see that tangent is negative. So tangent, principal values are first and fourth quadrant. Which one of those is going to give us negative values? Fourth quadrant, right? Because it's sine over cosine. So we can't get negative values right here whenever everything's positive. So it's going to have to be fourth quadrant. And I don't know which one it is because tangent's not listed, but I could narrow it down, right? Because it's going to be sine over cosine, and my answer has a square root of 3. So what does that narrow it down to? 330 and 300, right? Which I would call negative 30 and negative 60 for here. So I'm just going to test tangent of negative 30 degrees, which negative 30 is the same as 330 degrees. It would be sine, which is negative 1/2, divided by cosine, which is square root of 3 over 2. Dividing fractions is easy as pie. flip the second and multiply. What will happen with these 2's right here? They cancel out. I get negative 1 over the square root of 3, which is what I have over here. So theta will equal negative 30 degrees. If that didn't work, I'd go check negative 60, because that would probably be the answer. Yes?
Okay, so with our tan theta equals negative 1 over 33, we don't have to rationalize that thing.
You don't necessarily have to. If you do, you'll get negative square root of 3 over 3. But all you really need to check is which one matches this. So most of the time it's easier if you don't rationalize it. It can depend on the problem, but you don't have to. Because it's not your answer. If it was your answer, you would want to rationalize it. But you're just trying to see where theta equals this, and that is at negative 30. Or, what would that be in radians? Negative pi over 6.
You really have to check the other, only 2 when you figure out the first side.
No, you don't need to check the other one. It's not going to be both.
Okay.
Yeah. So since we saw that this is the answer, we don't really need to check 300. It's going to be negative square root of 3 there. So you don't have to check yet because it's only going to be one or the other. But if it didn't work, we would want to check the negative 60 and see, and it should.
Would you need to check it even with, there's gotta be an answer.
It is not going to give you the same thing because it's going to be flipped from that, so it won't give you the same thing.
Yeah, but if the first one's not it, the second one's gotta be it, right?
Yeah, pretty much. You could rule it out. Yeah, you could just check one, and if it's not negative 30, then it's got to be negative 60. Yeah. Yeah. Or you can memorize tangent, but I have not made you guys memorize tangent. I just need you to be able to figure it out. Because you can figure it out pretty quickly by just doing sine over cosine. There. All right. 4. Any ideas on number 4? Four has a tangent and a sine. And actually, it's going to be pretty easy, but it doesn't look necessarily easy to solve that. What do you think?
Can you divide by 10 on both sides?
If you do, that's a good idea, but if you do, you're going to lose an answer. Okay? So this one's going to have 2 answers, and if we divide both sides by tangent, it's going to cause you to lose an answer. So you may want to make yourself a note right here. Dividing both sides by a trig function causes you to lose an answer. That is an excellent idea. Because what we've got here is really sort of like when we do quadratics. So if I have something like x times x plus 2 equals 0, right, this is unrelated, but I'm just showing you the same principle. What we're using is called the zero product property, and it tells me 0 times anything. So I could just say x equals 0 and x plus 2 equals 0, right? I can set them both equal to 0. I can do that same thing here, but it only works if it's equal to 0, right? So if you have something that's factored and equal to 0, you can set each part equal to 0. If I had something like this, tangent theta times sine theta plus 1 equals 2, I could not do tangent theta equals 2 and sine theta plus 1 equals 2. That would be wrong because this only works for 0, and it works because 0 times anything is going to equal 0. But that's not true for 2. Something times anything, there's nothing where it always equals 2, right? So this is factored. We can just take tangent of theta and set it equal to 0, and sine of theta plus 1 and set it equal to 0. So if we move this 1 over to the other side, that gives us sine of theta equals -1 here. So we actually end up with 2 answers here because it's almost like we've got 2 equations that we're solving once we break it up. So I want to think about where tangent is 0. How do I find tangent again? Sine over cosine, which is going to be y coordinate over x coordinate. Sine over cosine, where is that going to give me 0? At 0. Because at 0, I would do sine, which is 0, divided by cosine, which is 1, and that would give me 0. So tangent of theta equals 0 at 0 degrees, or in radians, it's still 0 radians, right? So that is one answer, but not our only answer. We also have to think about where sine is -1. Where does sine equal -1? At 270, but 270 is not a principal value, so we should do what, Maggie? -90. So we'll say theta equals -90 degrees, or in radians, -pi over 2. On the homework, it's a good idea to try to give both answers. Actually on the homework, 1 through 6, I told you to do radian. Actually, I think I told you to do radians on all these. There. So this one, even though it's asking for principal values, you get 2 answers because it kind of broke into 2 separate equations. All right. So for 5, you have 2 options on the way that you can solve this. Okay? And both of them are relatively simple. So on 5, you could factor this. This would be cosine theta plus 1 times cosine theta minus 1 equals 0. So we could factor here. And if we do that, then we set, now that it's factored and it's equal to 0, we could set each one cosine theta plus 1 would equal 0. Cosine theta minus 1 would equal 0. So that would give us cosine theta equals -1 and cosine theta equals +1. Or, and we're not done, we need to get our answers. Or, another option here, we could add the 1. So we get cosine squared theta equals 1. Then what would I do to get rid of that square? I would take the square root of both sides. And when I do that, you just have to be really careful if you do it this way, because when you square root both sides, what have you got to put with your answer? Plus or minus. So if you factor, you're pretty much guaranteed to get the positive and the negative. If you do it this way, you just got to be really careful, make sure you remember that plus or minus, or you'll miss half of your answers there. So either way, we're looking at where cosine is +1 and cosine is -1. So where does cosine equal -1? 180. And remember, for cosine, our principal values are first and second quadrant. That would be pi if we did radians. And then where does cosine equal +1? 0 or 0 radians. 0 degrees or radians there. So you got 2 answers for that one as well. Okay, questions on that one? We really need to do this last one. We'll do it really quickly and then we'll be done. All right, so for this last one, we got sine x minus cosine x equals 0. There are no trig identities you can use here because those are not squared. They're already sine and cosine. We can't change anything. this looks impossible to solve. And in a way, it kind of is. It's not impossible to find the answer, but like you can't solve it the same way we've done the other problems. I'm going to take cosine x and move it to the other side. So now I have sine x equals cosine x. And I can't really do anything to solve this. I can't divide both sides by anything. I can't do anything to get rid of. I mean, I could do sine inverse, but then I've got sine inverse of cosine x. Very confusing. But I'm looking for where sine and cosine are the same, right? Which happens at 45 degrees. So x would equal 45 degrees. Or x would equal pi over 4. Now, this problem, your principal values for sine are from negative 90 to 90. Cosine is 0 to 180. But it really doesn't matter on this particular problem because even if you consider all three spots, the only place they're equal to each other is at 45 degrees. They are equal over here, but that third quadrant is no man's land. If it says principal values, we don't use it. Okay? So this will be our answers. All right. The whole rest of the worksheet. Yeah. Yeah, so just those 10 problems.